Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we'll look at traffic from SIP messages. So what is a SIP message? So think of this as short bursty SMS style messages over SIP. Now SIP has its own method called message, using which it ends up sending these text-based messages. Now these messages are clearly visible in plain text inside the message body. So let's actually jump in and take a look. So inside the samples call directory, let's go to SIP message. And there are a bunch of messages in here, a bunch of PCAPs in here. Now let's actually open up SIP message underscore SIP plus RTP. So in this case, SIP and RTP both are unencrypted. So let's actually open this up. And let's click on telephony, SIP flows. Select the flows, click on flow sequence. Now what you'd find is we see a new kind of message in here in the flow sequence called message, and this indicates that this is actually a SIP message sent inside a SIP packet. Now keep in mind that, depending on how much volume of traffic you're seeing, you might see these messages even kind of interlaced between other voice calls. So if you were to view what is actually there inside this packet, let's select the packet, go to the traffic panel, and if you notice, even Wireshark annotates with the word message here. And once you expand this, you'd see in the message request line, the method is message, and the message body clearly contains the actual message, which is a very simple hello world to SIP messaging. Now, similarly, you can actually see that this message is being forwarded by the server to the other party of this call, which is what is happening over here, right? Fantastic. So as you can see, SIP messages are very, very easy to figure out. Interestingly, you can even go ahead and dump these basically using T-Shark. So what we'd have to do is apply a filter for SIP.method equals message. So in T-Shark, if we do a -r read and give it the file, then we apply a filter, and in this case the filter will be for method is message. So this is SIP.method. So SIP.method equals message, and let's see if we can see these two messages with this filter. There you go, you can actually see these two messages. Now let's actually print them out. So if you select hello world to SIP messaging, you see that this is actually an object name called text. So we can just go in here, -t, we need a couple of fields. The field we need to extract is text. And there you go, we have been able to extract hello world to SIP messaging, right, as expected. Fantastic. So this is the case when, SIP is not encrypted. As you can already kind of like understand, the case where SIP is encrypted, so this would be the case for, let's say, SIP over TLS using just RSA, no Diffie-Hellman. And if you open this file up, you'd actually see that SIP yields nothing, but we see application data which contains SIP inside of it. So again, what we would require is a certificate if this is RSA based, which is what it is. And that is something we can actually verify in the server hello message. Oops. The server hello message. And we can clearly see this is plain old RSA with AES and does not have Diffie-Hellman. And what I've done is kind of left the key in the same directory called sip-messaging.key. So just like in the previous videos, we can click Edit Preferences, go to Protocol, scroll all the way down to SSL. And then add this new key in here. Port number remains the same, SIP, and then finally the key file, which is sip-messaging.key. Click OK, click OK. And you notice now SIP has been decrypted. So we can click on telephony, SIP flows, select all of this, click on flow sequence, and then once again we are able to see the messages, right? So we can select any one of these messages, go back here and see the message once again, right? So the key thing to realize here is if it is encrypted, then you would have to decrypt it first. Now the case where we have SIP plus SRTP doesn't matter because SIP is not encrypted. So the only time SIP is encrypted, we have to decrypt it first. Now, of course, as I already mentioned, the case where ECDHE is used or DHE is used, which is Diffie-Hellman exchange. So we have one PCAP file with that as well. This is the DHE-RTP.pcap. Unfortunately, there isn't anything that we can do with just the private key. So if you look at the selection of ciphers, you'd actually find that this is using elliptic curve Diffie-Hellman exchange RSA. And in this case, the only way out is either an MITM attack or dumping the keys on either one of the endpoints. Okay, fantastic. So the case where you can decrypt if you have the private key, excuse me, you could also use T-Shark just the way I showed you before, decrypt the traffic and recover the SIP messages, right? Fantastic. So this is all I had in mind for this video. If you enjoyed this, please recommend us to your friends and colleagues. Thank you.